All right, so this is still 9.1, still going on with radians and degrees and things like this, but these are applications. Oops, I spelled applications wrong. So these are applications of radians. Really, most of the things that we're going to be dealing with are in radians. So these are applications of radians. We just went through that example a second ago. We went through the example of changing the degrees to radians anyway. So the application of radians, we already know how to change degrees to radians. We already know how to change the degrees to radians. So here's how we can use that. Okay. So, okay. So the biggest application that we have and the easiest application is finding the arc length. So remember what arc length is. If we think of arc length as, there's no tool for me to draw nice shapes on here. So if we think of arc length, remember this is circumference of a circle. Around the outside of a circle is the circumference. Arc length is talking about a specific piece of that circumference. So arc length would be this part right here. It would be the length of that piece of the circle. So that thing is called the arc. Remember, this thing right here is the central angle. So just a couple of terminology pieces here, but this is the arc length right here. This would be the central angle, and those would be the things that you're dealing with. The way that you could find the arc length, which the arc length is represented by the letter S. So arc length is represented by the letter S. S stands for arc length. The way that you're going to find arc length is by taking whatever the radius is times theta. And now a big thing, and this is something that happened last year, I don't know if you guys remember this or not, but theta must be in radians. All right, so it must be in radians. It has to be in radians. If it's not in radians, this will not work. If you leave it in degrees, it does not work. Okay, so if we're looking for the arc length of something, I know what my radius is. It doesn't matter what measurement the radius is, because the radius is just talking about right now the radius of a unit circle is just 1. So whatever the radius is, it's just going to be a multiple of 1. So it doesn't matter if it's in meters or feet or whatever. It's just specifically talking about this. The meters or feet or anything is going to change the unit on your arc length itself. Okay. So if I give you a question that says something like, find the arc length of if, actually, let's say if the angle is 90 degrees, actually, let's not do 90, 90 is too easy. 50 degrees and radius is 3 meters. Okay, so if I have something that looks like this, where it asks me to find the arc length of something where the angle is 50 degrees and the radius is 3 meters, the first thing I have to do is change this into radians, and then I have to be able to plug in that radius. Okay, so the first thing I'm going to do, and I'm going to do it the way that's easiest for me, because I think that's the easiest, and I think that it's the most efficient. So if I'm going to change this, the first thing I'm going to do is find what theta is. And the way that I'm going to find theta is by changing it into an actual radian. So I'm going to take my 50 degrees and I'm going to multiply that by pi over 180. So I have pi over 180 degrees. If you want to do it your other way, you can. I don't think it's as efficient, so I'm not going to do it that way. Okay, so it's going to be 50 pi over 180. And so now I could simplify this down to 5/18. So this would be 5 pi over 18. So I can, if I could simplify it more, I would, but I can't. So now remember, my arc length is radius times angle. The angle is 5 pi over 18. So my arc length is going to be equal to 5 pi over 18 times 3. Remember, when you're multiplying fractions, you only multiply on the top. It won't give me any bigger dot here. So it's 5 pi times 3, which is 15 pi over 18. And then I could simplify. If I could simplify, I would, but I can't. And the unit on this would be meters. So it would be 15 pi over 18 meters. Now, if you were asked to estimate, or if it asked you to round the nearest decimal or whatever, you could, but this is the exact answer because obviously pi is not an exact answer. So 15 pi over 18 meters is the non-exact form of this, and that's what it looks like. Okay? Questions on this?
Can't you simplify 15 over 18? Divide both
Oh,
sides by
I could, right? I could. Thanks, Jake. So 15 over 18, I could simplify down. I could take a 3 out of both of them, right? So it's going to end up being 5 pi over 6. Good catch. So it should be 5 pi over 6. This would be the simplified version of that. I would have gotten that one wrong. Any other questions or issues on that one?
I'm just wondering why you didn't, cross simplify 3 and 18.
I could have. I absolutely could have. I just didn't see it. That's just something that I didn't check, because you could also do this, and then like Blake just said, 3 and 18 simplifies down to 1 and 6, and then you make your life easier. So that's just something that I didn't check, so that's my fault for that part. But that should be something that hopefully you guys recognize and can check. Finding arc length and finding things like that are usually pretty easy. They're usually pretty easy to work your way through. The only thing that's going to be a little bit different is there are some questions in your book that would say something like one of the questions says, find the radian measure. So it would say like, find the radian measure. I can't write on this thing at all. Of if you were given a radius of, let's say like 14 feet. And then an arc length. So I'm going to use S. Remember, S is arc length of 8 feet. I need you to be quiet, okay? So radius is 14 feet. Arc length is 8 feet. So now what we're going to do is we're just going to use the formula that we know. Remember, the only formula that we have for arc length is S equals R times theta. So it's asking me what the radian measure is. So that's basically saying, what is theta? Theta becomes our X. So if I know what my arc length is, which is 8, and I know what my radius is, which is 14, now I can solve for my angle. That's gross. Can you throw those away and then wash your hands? She held on to her Skittles and they all melted in her hands. So here what I'm going to do is I'm going to just divide by 14. Okay. So I'm going to divide by 14. And then I could use my calculator if I wanted to. But notice how there's no pi in here. There is no pi in here, which means that this answer cannot be exact, which means that you're allowed to estimate the radians here. So since there's no way for me to figure out what that pi value is, I mean, you could if you really wanted to, but since it's not here and it's not efficient for us to do, then we would just do 8 divided by 14, which, does anyone know what that number is? Does anyone have the calculator with them right there?
0.5714.
Okay, so let's just call it 0.57. So this is saying that it is 0.57 radians. Now you could also, if you wanted to, we could go through and we could cross multiply, cross simplify, whatever we needed to do to figure out exactly how big that thing is. Okay. Any questions that you guys have or any issues that you guys have with that? All right, so let's work through, this is just another thing that I want to mention, and I kind of just want to introduce it today. And then once I get done introducing it, we'll kind of stop. I'll see if you guys can kind of figure it out on your own. I'll give you a couple practice problems, but that'll definitely be where we pick up our conversation on Monday. All right. So the two other applications that we can have, and if you've taken physics, you probably heard these at some point. Linear speed, which is really just talking about velocity. And then the second one is angular speed. And this is really talking, angular speed is like, so like linear speed, basically the definition that goes along with it is it's talking about how fast something is moving. That's what velocity is, right? So this is how fast an object moves. And angular speed, obviously we're talking about an angle here. This is how fast an angle changes. So one thing to kind of think about with this is basically angular speed is talking about things like RPMs. It's talking about when things move and rotate and how fast the tire can rotate or how fast. Basically, what we really talk about is we basically talk about how fast something rotates, like RPMs, how fast the tire rotates. That's the most common application of this thing. So angular speed is how fast something rotates. Linear speed is how fast something moves in general. So there's a big difference between movement and rotation, right? So if you think about a wheel would move, but it would have to rotate in order to move. The angular speed is the rotation that makes it move. And then the linear speed is that object in motion, it's actually moving, okay? So these formulas they look like this. Linear speed is always talking about distance over time. And that makes sense, right? Because it's how fast an object is moving. It's like in miles per hour. So distance, how far you've traveled over the time that it's taken to get there. Now, when we're talking about distance, we are talking about the arc length. Okay, we're talking about arc length. Because even if you want to think about it this way or not, if we're on the Earth and the Earth is circle, or a sphere, it's not a circle, it's a sphere. If we're on that Earth, we are moving at a portion of that arc length, right? If I run, I'm still running around the Earth, which means that I am still following a curve. So arc length is talking like this. So the distance of something is really talking about the arc length over whatever the time is. So the arc length, we just figured out, we could figure out the arc length by doing radius times theta over whatever the time is. So if you're looking for linear speed, you're looking for the radius times the angle, whatever the angle is, over the amount of time that it took you to move there. Now remember, theta still has to be in radians. It's not changing. So theta still has to be in radians. And now when we talk about angular speed is just talking about the angle period. That's what it's talking about. So angular speed is just talking about the angle that we're using, and that's it. So angular speed is talking about the angle change over time, like how many times the angle has moved. So if you think about a tire, if we think about RPMs, the way that you count an RPM is it does one full circle, right? Like if you wanted to count how many times the tire moved, you could put a dot on that tire, rotate the tire one time, and then once it gets back to the same spot, it's rotated one full time. Now, if you want to count how many times it's rotated in an hour or a minute or a second, that's what RPMs are. RPMs are revolutions per minute. So how many times does it go around in 1 minute? So if we wanted to do that, we would take the angle that it moves, which every one of those angles in an RPM would be a full circle. That is my angle, 2 pi in radians. 2 pi is a full circle. That is my angle. And then you divide that by how much time. So how many rotations they did by how much time, and that gives you your rotation per minute. Okay? So the way that you're going to do this is you take your central angle and you divide it by time, which basically means that we are doing angle over time. Yes, I will open that for you. Here. Okay? Now, linear speed is represented by V, so the equation that you should use with this is R times theta over T. And then angular speed is represented by W. So angular speed is represented by W, so this is W equals theta over T. Okay? The biggest difference is this one, we're multiplying it by the radius to figure out how far we're actually traveling. This one, we're actually using it for just the angle. Okay? So I'm going to leave that for right now because I know that I've been taking 40 minutes and I told you I was not going to try to take 40 minutes the whole time. So I'm going to call this good for right now. I will put some questions on Google Classroom for you guys to attempt. There are going to be a couple linear and angular speed questions on there because I want them to create questions for us next time we're in class. Okay, I want them to create a discussion for us. So let me stop recording here.